Something that data scientists do a lot is work with charts and graphs. And this is because when you're working and trying to identify complex patterns in data, it's easy to see if you can look at it. It's hard to see if you have to examine the numbers themselves. So charts and graphs help the data scientist do that. And we're going to take a look at how they do that now. So the first thing we're going to do is we're going to start with the data set, which is exactly the data set that we were exploring before with student data. We'll go ahead and run this, and this will pull in the grades CSV file, which we already have, but it'll get pulled in again because we've made additional requests for it. See right there, grades CSV.1. And then here, we're pulling in the grades, putting that in a data frame like we talked about, adding that passes column, whether or not they passed or failed, and then just printing out the data frame here. So it's exactly what we had before when we were exploring the data and learning about data frames. By the way, when I jump over to these CSV files here, you might notice that they're different colors, and this is powered by an extension called Rainbow CSV. You might want to check that out right here. So one of the cool things about Visual Studio Code is extensions, and there are tons of extensions for those of you doing data science, working with data, one of those being Rainbow CSV. All right, so we've got our student data. Now we want to make a chart or a graph. So to do that, we're going to use a library called Matplotlib. And again, if you don't have this installed, you can just in your terminal run conda install matplotlib, just like this, and that will install it. So if you run this and you get an error, try installing matplotlib in either Python using pip, or if you're using Anaconda like I am with conda install. So first, let's pull in matplotlib here, and then we're going to import pyplot, which is the plot. Plots are the charts as PLT, and that's what we'll call it here, the variable PLT. Now, what we want to do is create a bar chart here to look at this student data. And along the x-axis, we're going to put the student's name, okay? So name across the bottom, and then we want their grade across the side. So you would think that the y-axis would be called y, but it's not. When you're using Matplotlib, the plot item here, it's called height. I'm sorry, I didn't name it. And here we're going to put the grade for the students. And with that, we can just go ahead and say plt.show, and this should be all we need to create a bar chart of the students and their grades. And there we go. We have a bar chart. It's not easy to look at, but there it is. So let's take a minute and customize this chart and make it a little easier on the eyes. So let's start customizing here. Let's add a title to this chart, which is called student data, student, I'll tell you what, let's call it student grades, or descriptive there. And then let's add a label to the x-axis, which is just x label. We'll call this name. And then the y, which was height before, is actually now y label. It is y label, and we'll call that grade. And then the most problematic thing with this chart is that these X ticks are all running together and you can't read them. So if we turn them 90 degrees, they'll be a lot easier to read. So let's go ahead and do that. Let's say plot.xticks, and then we're just going to say rotation equals 90. So we're going to rotate them 90 degrees. So let's go ahead and run this. And now this chart's a whole lot easier to read because we can actually read the names on the bottom. And there's our favorite student, Vicky, with that horrible score. So we can also do things like change the color here. So if we change the background, say, excuse me, not the background, but the color of the bars, this will change the color of the bars to orange. So we have a lot of control over the charts and the way that they look. When you're working with charts, what we've got here is something that we've called a plot, but it's important to be specific. Plot is actually the chart. That's the plot. The whole thing itself, if we include all the way out to the edge, that's called a figure. Now the figure can have multiple plots or charts within it, and the figure is created for you automatically if you don't specify it. But if you do specify it, you get a lot more control over the size and shape of the chart. So up here at the top, we're just going to define a variable called figure, and then we're going to say that that is a plot figure. And then once we do that, we can start to change the dimensions of the plot itself. And we can do that with fig size. So we might want this chart to be wider or taller, just changing the dimensions. Now the fig size takes two variables, a width and a height, but they're in inches. So for instance, if we wanted a chart that was 10 inches by 4 inches, 10, 4. But because we're dealing with screens, we don't think in inches, we think in pixels. So one thing that you can do here is, because the DPI is 100 by default on these plots in Matplotlib, you could just multiply by 100 to get the pixel. So this would be 1,000 pixels by 400 pixels. If we wanted something that was 1280 by 720, that would be 12.8 by, that's right, 7.2. And we actually don't need to change anything else. If we just go ahead and run this, it will resize that chart to that size. So that's an important thing to know, is just how you make charts bigger or smaller with Matplotlib, and you do that with the figure and fig size. Okay, now as we said, this whole thing is called a figure, and a figure can have multiple plots. Those are charts. And that's commonly done because it helps us visualize data, and we're going to do that now. When we want to have multiple plots in a figure, we need to use the subplots item on the plot element there. And then where the fig size is, the first thing we need to tell it is how many rows and how many columns this figure is going to have. So in this case, we want to have 1 row and 2 columns. And the fig size is a little bit big here. Let's take this back down to 10 by 4 or 1000 pixels by 400 pixels when you don't change the standard DPI. Now, we no longer are working directly with the plot element, and instead we're working with an axis element, all right? So that actually is returned by the subplots here along with our figure. And then we'll just say on the first axis, okay, we have 2 columns, 0 and 1. So we're going to put a chart in the first column, which is AX0. A chart in the second column will be AX1. So in AX0, we're going to put a bar chart, and the rest of this pretty much stays the same. Now we're no longer working with the plot element, and instead we're working with this AX0, right? That's where we're defining the plot, and instead of title, it's set title. And instead of all this stuff here, we're just going to have this AX0 like we did before down here. And instead of xticks, we're going to say set xtick labels. And then inside of that, we're going to say dfstudents.name, and then we're going to rotate the labels 90 degrees just like we did before. And this gives us basically the same bar chart that we created. Now we want to create a pie chart to show the pass and fail totals. We're going to put that next to the bar chart. So to do that, we're going to get a total count of all of the passes. So a count of how many people failed and how many people passed. So to do that, we're going to take our data frame and we're going to look at the passed column. And in order to sum up all of the people who passed, all the trues and all the falses, what we need to do is use the value counts method here, which will give us a sum of all the trues and a sum of all the falses, 2 values. And then we want to pass those in and make a pie chart. So on the axis 1, which is the second column, we're going to create a pie chart. And in that pie chart, we're going to put the pass counts as the data that we want graphed. And then for the labels, we're just going to use the pass counts as well, because that's going to tell us true or false. And that's all we need to know here. And then just like with the bar chart, if we want a title, we can call set title here and pass in a new title. Let's call this passing grades. Perfect. And then finally, we're just going to call fig.show, right? Because we don't have a plot element anymore. We have a figure element. Okay, so let's go ahead and run this and see what we've got. All right, we got an error. We did get charts, but one of them didn't render and we got an error. But this is great because it gives us a chance to debug this and see what went wrong. So if we come up here to the top here, we can see this, which is called a stack trace. And we can see it's telling us line 11 here, this line, this label right here, it's telling us got an unexpected argument label. Okay, and that's because it's labels, not label, right? And this is what makes programming kind of tedious sometimes. It's because you have to get this exactly right. So let's change that, run it. And now, look, we have our passing grades on the right as a pie chart and our student grades on the left, 2 plots, 1 figure. All right, now it's worth noting that charting and plotting is so foundational to data science that you don't even need to use Matplotlib directly. It's kind of built into the data frame itself. So we can actually plot this or chart this directly from the data frame. So let's call df students, and then let's just say that we want to do a plot. What kind of plot? Well, we want a bar plot. On the x-axis, we want the name, and in this case, it is the y, not the height this time, which is nice. So on the y, we want what? We want the grade, and then we can actually set the fig size here as well. So let's set that equal to 10 by 4, seemed to be a good one. And then just like with the previous chart, we can set the color. Let's set it to something else here. This is actually all you need to create a nice bar chart. Really easy to do directly off the data frame. All right, now it's time to get into some actual data science here and figure out what's going on in this data. And what we want to do is take a look at these grades. And something that data scientists are often interested in when looking at data is the distribution of that data across the sample. Now, what's a sample? The sample is the data that we have, okay? The grades. The grades here are our sample. And then there's the population. The population could be any student who might ever take this class. So we look at data for the sample because we can't look at the entire population. And then we make an assessment or a judgment about the entire population based on the sample we have. The larger the sample and the more data points, the better our prediction can be for the entire population. When we examine the distribution or how the data is spread out across the sample, a great chart for doing that is called a histogram. So in our notebook here, let's create a histogram. So let's get some data here. We'll just call it grades, and then we'll just pull in from our dsstudents.grade column. And then let's create a new figure. And then we're gonna just say that we want to plot with a new figure. And this allows us to set the fig size, right? And then we'll just make that 10 by 4, I think is what we've been doing so far. And then we're gonna use the plot item to plot a histogram. We're just gonna tell it that we want a histogram, and we want the histogram to be the grades, the data that's in the grades variable there. Now, just like we did before, we can customize this. Let's add a title. Let's just call it data distribution. And then let's go ahead and set our X label. There we go. And we'll just say that this is the value. And then we'll set our Y label. And this is the frequency at which this occurs. And then let's just go ahead and show this figure and run this. And we get a histogram. So let's talk about what we're looking at here. The histogram shows the distribution of the data, again, across the entire sample. So from 0 to 100, this is where the data falls. So you can see that most of the grades are actually right between about, what, 30, 40, the low 40s and 60, right? Maybe mid 40s and 60 right there. So most people scored between about a 45 and a 60, and that's why that's the tallest point. And then over on the very right, you have the people that scored the highest grades, which is only a few of those. Then over on the left, you have Vicky, who's bringing the whole average down. All right, so this histogram is a symmetric shape with most of the data being in the middle and the fewer being out on the edges, which is quite common when looking at sample data for a population. So another thing that data scientists do when looking at a histogram like this is try to define what's called the central tendency. And that basically means what's the middle point of the data. Now there's a couple different ways that you can measure this. One of them is something called the mean, which is an average. Another one is called the median, which is the number that is right in the center. If you line up all of the data from lowest to highest, what's the number that's right in the middle, equally from both ends? And last is the mode, and the mode is the number that occurs most often in a sample. So let's go ahead and add that to our chart here and see if it tells us anything different. All right, so right here, before we actually plot our figure, let's go ahead and get the min value, which is our students.grade.min. So next, we're going to look for the max val. We're going to set that equal to dfstudents.grade.max. And as you can see, these lines are starting to look very similar, and we actually need the mean, the median, and the mode. So in VSCode, we can use a shortcut here to do that, where we copy down lines, and we do that using Option-Shift-Down. And that just copies the line down, and we can do that 2 more times here, right? So here, instead of max val, we want, let's say, the mean, and then let's come out here to the edge and get the mean. And then for this next one, let's do the median. Actually, just call it, there we go. And then pull in the median. And all of these are built-in functions right on the data frame, which is really nice. And then the last one is the mode. And as you can guess, come out here and ask for the mode. The one difference with the mode is that you might have multiple numbers that occur the same amount of times, right? So maybe the score that occurs the most is 65, and then the score 68 also occurs that same number of times. And so because of that, mode is a list of items, so we need to make sure we get just the first item just by asking for that 0 placed item there. All right, so let's go ahead and print these values out so we can actually look at them. And then we want to add this to our chart. So to plot lines on a histogram, you use the AXV line method here, and this adds a line. We need to tell it the line, the value that we want to add here is the min value. And then we can do things like specify the color, okay? Now, because we're going to need a line for min, max, mean, median, mode, Again, we can just use the Option Shift down or Alt Shift down on Windows key to copy lines down just like this, right? So we can make this one, this is the min, we can make this the max val, it can also be gray. Let's make this one the mean val, and let's make it cyan. And oops, I capitalized a V here, and we get that nice squiggly to tell us that it doesn't recognize. If you see that squiggly? If we actually mouse over, it'll tell us it's not defined, which means we used the wrong variable name. So let's go ahead and correct that. And then we can make this one the median value, and let's just make that red. And then lastly, let's take this and make this the mode value, and let's make that yellow, should be fine. Now that we've done all of that, let's go ahead and run that again and check out our chart. So now we have a histogram and we have our lines here. So if you remember, the gray line is the min, this gray line is the max, this is the mean, median, and mode. And in our sample, they all happen to be in the middle, right? We could pretty much tell that by looking at the histogram. Some histograms aren't this neat. It's not as easy to see, so it's helpful to chart those lines. In our case, they are all right smack dab in the middle. That is the central tendency of this sample. Now, another chart that data scientists use a lot to examine central tendency is something called a box plot. So let's make one of those. So let's go ahead and define that grades variable again. We actually don't need to do this because it's already in the notebook and it will remember from previous cells, but let's go ahead and do it just so that we don't get confused about what data that we're looking at here on the grade. And then let's go ahead and create a new chart here, a figure. We'll say the fig size is 10 by 4, just like we've been doing. And then let's go ahead and add a box plot, just called box plot there. And we want to pass in that grades data. Perfect. Then we can set the title. Oops, title. There we go. We'll just call this data distribution. And then we'll go ahead and show the figure. All right. So what does a box plot look like? Let's find out. This is a box plot. What a box plot does is it shows you how the quartiles of the data are split up. What does that mean? It means that if you separated the data into 4 equal groups, where would they be in this chart? The middle 2 quartiles, right? So 50% of the data is actually here between about 36 and lower 60s. Can't tell exactly. 50% of the data is here. 25% is here. 25% is here. So this is called a box plot. These are often called whiskers, and this is something else data scientists use to measure central tendency. It's often useful to combine histograms and box plots together to get a clear sense of the data. So to do that, I'm just going to copy in a bunch of code here. And this is code we've already written, right? Min, max, mean, mode. And then we're using the subplots. So 0 is our histogram with our lines on it. And then 1 is the box plot here. And then we're just showing that. That's it. We're not doing anything special here. I just want you to see me write that code all over again. I'm going to remove this for a second and run this. And then we'll see that we have both of those charts now in the same figure. But the box plot doesn't help us much because this chart goes this way and this chart goes this way. And that's why I removed this value here, up here, where it says box plot. So what we can do is just say vert and just set that to false. Let's run this again, and this will display the box plot horizontally, just like the histogram, which helps us understand it a little bit better. And again, we can see here that it matches, right? Central tendency is right smack dab in the middle, 50% of our grades being right around here, just a different way to visualize that central tendency. Now, we talked about samples and populations and how a sample is a subset of the population. It's the data that we have, and we try to extract insights about that sample so we can make predictions about the population. If we have enough samples, then we can calculate something called a probability density function that will let us make sort of assumptions about the population at large based on the sample. The pie plot, which we've been working with in Matplotlib, provides a very handy plot to do just this. So let's create a function to do this, actually. When you have a lot of code, it's very nice to put it inside of a function, and the function just sort of encapsulates all the code that goes together, and you can call that function later on. So here, let's go ahead and create a new figure, and we'll say plot figure, and then fig size. You should be an expert by now at these figures. And then we'll go ahead and say that for this data here that we've passed in, we want to plot and we want the density. And remember, we can call the plot directly on the data because it's a data frame, and data frames have that charting built in. And then we can set some additional things here, like we could add the title. So we'll just call this data density. There we go. And then lastly, we just need to show this thing. And then how do we call this function? Well, we just sort of call it. So we'll just click show density, and then what data do we want to show up on the plot? The grade. So let's call df students and the grade, and we'll pass that in as the data. So let's go ahead and run this. And this is our probability density, also known as a bell curve. You've probably seen these before. So you can see that the grades are distributed right here, right, with the outliers on the edge. It looks just like the histogram. So from this, we could make some sort of assumptions about the data, or the grade, the class, the test. We could say the test was too hard if more people got a 50 than got, say, a 75, and maybe we want to move this over to the right, so we want to grade on a curve. But that's not really the kind of conclusion that data scientists are often after. You don't need charts and graphs to determine if you need to grade on a curve. Teachers do this all the time. What a data scientist would do is actually look at how the different points in the data relate to each other and figure out if there are some predictions that we can make about the population based on the sample. And that's what we're going to do in the next video.